Very good. Base times height. So we wrote area of a parallelogram was base times height. Area of a triangle was half base times height. Area of a rectangle was, hey, look at that. It's base times height. Whew. I know, we should pace ourselves. It's really difficult. And then the area of a square. Or sometimes we said side squared. And then I think the last one we had yesterday was a trapezoid. And that was half of the height times the sum of the bases. Okay. Look, I think those were the 5 we used yesterday. I know we had circles, but we'll come back to circles here in a little bit. So. Let's see what you did there. We'll get it back around to that. We'll circle back to them later. Sorry. I'm sorry. Anyway, so what we did here is we walked through a whole bunch of problems. I can't imagine that this was difficult. But what I want to do is talk about what are called composite figures a little bit today. We'll do 2 of these. I think we'll do 2 first. A composite figure is a figure that's made up of 2 shapes. So the biggest thing you have to try to figure out here is, what are the 2 shapes? Now, Josh, please, pace yourself. I'm messing around here. So when you see one of these things, we'll have these things called composite figures. Composite figures are going to be shapes that are made up of multiple shapes. Sometimes there'll be shapes that have holes that cut out of them, different designs, things like that. So sometimes we're adding things together, sometimes we're subtracting things together, depending upon the types of problems and things that we get. Now, excuse me, as we get into this more, in this one here, we've got a square and a triangle, just like Josh so eloquently described for us, which means when you have these 2, we have to basically just write out the formulas for both of them. So your area, we have an area of a square and an area of a triangle that we have to put together. And like I said earlier, whenever we do these things, as you write down your formulas, it becomes so much easier to see what you're doing. That way you don't get stuck on a problem later.
And guys, that's true for this chapter. When we get to the next chapter, that's surface area and bounding.
Yep.
Start with the formula. People use circles and sectors.
It makes it so much easier. Yep. What were you going to say, Josh? Good conversation. So, just like Mrs. Thrower was saying, guys, I know that we're kind of making a little bit of a joke here and there with some of these things to start out with, because they are ridiculously simple. But as we get into the more complex things, when we have 3-dimensional figures, when we have different shapes and we have bases and different things and all these different formulas going on, the more that we write it out, the easier everything becomes, because it's quite literally substitution as you get. So we start with, like we always start with something easy. So our side lengths are 6, so it's 6 squared plus 1/2. What's the base and height for the triangle? 6. Now, you could literally type in exactly what you wrote down there, because that's kind of how math works sometimes. You get how much, Josh? 60? So you have 36 and 24. You get 60. Oops. 60 square inches. Don't forget the label. 36 and 24. I labeled it. You're proud of me. I know. Takes a lot to make you happy. Simple things in life, right? The simple things in life. Okay. Again, like I said, this is fairly straightforward. Really not a lot of crazy here. But sometimes they'll make you do a little bit of work. Sometimes they'll make you do a little bit of work. Okay. draw that out, you got to figure out a couple of parts out of this one. Hey, somebody go do the problem. We're busy. What do you have to figure out? Oh, it's like an old man. Oh, it hurts.
I woke up at 4 a.m. this morning.
That's two words for you. Oh, that's pretty good.
What are your two shapes here?
Rectangle and a triangle.
You guys know what a CD is?
What? A CD?
CD.
A CD? I don't even know what it's for.
You know it's an option now to get a CD player in the car? They don't even run the car.
They don't do that no more?
No. Yeah. Seriously, it was crazy. Yeah, you can't. There's a lot of cars that don't have CD players. When my wife was looking to get a new car, she was, you know, you have to go online and build the cars you like and get all the options. So it was her cost. And she was looking at it was Highlander. What she was doing, she was looking at Toyota Highlander. I'm thinking she was looking at the Highlanders and it was like a $300 option to put a CD player.
Oh, it's
60.
Wait.
You're supposed to divide the one half into
Well, let's see. Here are your two shapes.
Rectangle and a triangle.
Did you write that down?
I did.
You just rotate that to a
Where'd you get that for?
Yeah, where'd you get the 4 from? He's got a 4 there, but I don't see a 4.
Yeah. I know where
Okay, where is it?
I'm at. Right here. Because this is 12. 60 minus 12.
So it's kind of like that segment addition that we did, oh my
Stop
word,
yourself.
in chapter 1.
Stop
See that? See how we keep building? That's chapter 1 stuff, you guys. Who remembers that? When we did the segment addition.
I remember the words.
You remember the words? Yeah. So if we gave you the whole part, the whole thing, and we gave you one little part, you had to subtract. If we gave you 2 little parts, little part plus little part.
You got a
had to
broken
subtract.
cap here, sir.
I know, I think it's really had glue.
We had some tape.
Again, a lot of this stuff that we're gonna be doing, guys, is we're gonna be adding shapes together, and then tomorrow we'll do some stuff where we're gonna take the shapes out. We'll do a little bit of both. Yeah, I gotta do a little bit more. And the same thing here, there's a couple in the 10-2 they wanted to show, because they throw a couple trig problems at you here. So I just want to show you guys, make sure you understand how you can get some stuff using some trig. nothing too crazy. There are a couple of formulas that we did not talk about. We didn't talk about the area of a rhombus or an area of a kite. So the area of a rhombus. Remember, a rhombus. Oh, jeez, I can't. A rhombus. I gave up. Yeah, if you want to do that. Rhombus has all four sides that are congruent. It has all four sides that are congruent, and it has diagonals that are perpendicular. Now, one quick reminder, when you start seeing perpendiculars, you know we're going to have right angles, which means in the back of my head, I have to remember that a lot of times I'm going to see a squared plus b squared equals c squared, or I might have to use this is where a lot of these types of combination style parts will show up because it's pretty common. So the area of the rhombus, and actually the area of the kite, have the same formula. It's going to be equal to 1/2, so just a bit, diagonal 1 times diagonal 2. And not in a rhombus. Okay? Remember the rhombus? they don't necessarily have to be the same. No, because remember you'll have the sides that are all the same, but you don't have your opposite angles are still. So that diagonal 1, diagonal 2, things they still get bisected. Things like that. All those properties still hold true, but we're just looking at the two different diagonals. Okay. The diagonal goes from side to side. Then the kite is basically the exact same thing. It is the same formula. But remember, with the kite, you have two isosceles triangles on top of one another. If you want to think of the easiest way. So when you have a kite, kind of like that. Same deal. When you had a kite, you had these two guys were the same. Those were the same. And then you had your right angles here. Anyway, I know that we've worked with these. We've done a lot of this stuff. They're pretty easy. Just wanted to show you the quick formulas here because we will have stuff like this to worry about. Notice they start throwing angles at you. Now, there's going to be a couple different ways of doing this. Obviously, here, this is a 60 degrees. So if it's a 60 degree, that means, well, first of all, draw it up and we'll see where we go. Sorry, I don't mean to get ahead of you here. I start seeing trig and I get. Now we've had stuff like this before, where you kind of had to redraw parts to show where your heights and stuff were. But in this case, do we know what the value of the height is? No. Okay. But we know that this is a trapezoid because we have the right angles here. So these guys, we're going to get a trapezoid out of this. So we have our two bases. But if I take this segment here and move it here, isn't it still the same segment?
Yeah.
Still the same height, isn't it? Yeah. Now, I moved it over towards the left. How much is left for this portion by the triangle or by the triangle now? If this part up here is 5, that means this chunk here is 2. If this part's 5, you okay with that?
Yeah.
Now there's one of two ways you can go about doing this. If you remember your ratios, because this is a right angle, which makes this up here 30 degrees. If you remember your ratios of the special right triangles, you have a 30, 60, 90. If you don't remember the ratios of your triangles, you're trying to figure out what the opposite is, knowing the adjacent. There's one of two ways of doing this. Opposite over adjacent is what? Tangent. Good. So I can say that I can do the tangent. So the tangent of 60 is my opposite over 2. And just like we did last chapter, when you had to figure out what was the numerator, what did you do with the denominator? Now you just multiply over. So you would type in your calculator 2 times the tangent of 60, and that gives you whatever your opposite value is. Or if you remembered your ratios of sides, if you did it that way, you know across from the 30 is 2, and that gives you your height of 2√3. You get the exact same answer. So our height for this problem is 2√3. So then you go into your formula. You've got your, the area is 1/2 the height, sum of the bases. So that's 1/2 2√3 times 7 plus 5. And again, I can type that directly into my calculator, and it's going to give me my answer with that √3 in it. And that becomes an exact answer. Correct me if I'm wrong. If you type it in just like that with parentheses and everything, the √3 and the half, it gives you 12√3, correct? Does it do that? Nice. There's your answer. Your area of this problem for this one is, as an exact answer, 12√3 meters squared. Now, if the problem said round to the nearest hundredth, what would you press? Double arrow. What do you get when you do the double arrow? How much? 27.8? Or approximately 20. It's quite literally taking a little bit of the things that we did last chapter and just mix it into the shapes. Didn't go away. No, just like I never taught you how to add or subtract, but it didn't go away. It's very, very common. Like we're saying here, guys, this really is very simple. There's not a lot of trickery here or tomfoolery. Where'd that saying come from? Was there a cartoon character named Tom Fool or Tomfoolery? Is that what it is? I think so. You know, if I only had the internet, I just don't have the internet.
I wish somebody could invent something that you could like.
Look things up like
Yeah,
instantaneously.
like a search thing, you know, type it in.
It'd be
So much easier.
there's only a way to figure these things out.
I don't even like that now.
No, right? So algorithms, so tired of arguing with somebody at a bar. Oh, I'm right. No, I'm right. Let's look it up on the internet. Hey, what kind of a shape is that? It's a kite. How do you find the area of a kite? Oh, where's it from?
Came from a very old poem. It's used to describe beggars and vagrants who were particularly mad. Tom is more than a shortened term of Thomas. It was in the 16th century. It became
Huh. We're using 400-year-old.
hence Tom.
That makes sense then. Wow. Huh. So we're using 400-year-old slang in here today. They were probably doing stupid type problems back then too, without a calculator. Oh. Blessest thou kitest of the sky, Two hasses diagonals of love and divine. Upon yonder, I'm losing it. Yeah, I'm so not even. Oh, I got a beat now. Upon yonder starlight of love, the kite fliest high in the sky. To shallest area be so divine. Poor Alicia, she's like, I moved here for this crap. So what happened? Can I go back? Sorry. This is tough. 3 plus 3, and then 2 plus 5. All right. So we have diagonals of 6 and 7. Whew. What's half of 6? 3 times 7 is. Once again, this is just. I'm trying to make this look a lot more difficult than it is. I don't think it's working very well. I think the last one I have has got the. No. All right. So what we're going to do here is I have 2 sets of problems out of the text here. One from 10.1 and one from 10.2. So let's see. In 10.1, it goes on page 619. Those. And 10.2. What's that? I know, right? It's weird, right? Oh, right down page that. That's on page 626. $15, sir. Yeah, what is that? 5, 7, 8, 9, 10, 11, 12, 13, 14. Pretty sure you'll knock it out here in no time flat. If you don't have your Chromebook, if you wanted to snap a quick picture of the textbook while it's out, please do so, but I expect you guys to be working. Oh, well, here's have a book sit next to you. You get to use the book then, and other people get to visit you. All right, go ahead and get started. Like I said, guys, this shouldn't take very long. If you want to listen to music while you're doing that's cool. But playing video games while you're doing it's not cool. But yeah, you guys go knock this out in literally 15 minutes tops. There's only a couple of tricky ones for the trick. I think it's like 3 of them. Yeah. Oops, wrong button.